The next topic in section 15.1 is on the curl of a vector field. We first are given the definition of curl of a vector field, which is equal to, if the vector field is a vector field in space with components m, n, and p, we find the curl by taking the partial of p with respect to y minus the partial of n with respect to z, minus the partial of p with respect to x, minus the partial of n with respect to z, that's your j component, plus the partial of n with respect to x minus the partial of n with respect to y. Now this is adapted by using the cross product, finding the gradient of this vector field. Now the way we test for conservative vector field in space is by calculating the curl. If the curl is equal to the zero vector, we can say that f is conservative. And in order for this curl to equal zero, each of these partial derivatives must be equal. To find the curl of the vector field given by this, that's our example. We want to find the curl using the formula, and we want to answer the question, is f irrotational? Well, if the curl is equal to 0, then we could say f is irrotational. The curl is given by this, the formula given on the previous slide, or by evaluating it in this manner, the gradient cross product with the f of x, y, z. And if you write it this way, using your ijk vectors, the way you find the gradient is taking the partial with respect to x, the partial with respect to y, and the partial with respect to z. And then your original f vector here, 2xy, x squared plus z squared, and 2yz as the components. We can find the determinant of this matrix by using the expansion by minors to find the cross product. So if we take, cover up the J and K columns, and we can cover up the I columns, and you find the determinant of this matrix, find the determinant of this matrix, and those are going to be your components of the curl. If you take the partial derivative of this with respect to y, you get 2z. The partial derivative of this with respect to z, you could get 2z. When you subtract, you get 0. For the middle, we want to find the determinant, take the partial of this with respect to x, and that's going to be 0. The partial of this with respect to z is also going to be 0. And then the last determinant, the partial of this with respect to x is 2x, and this with respect to y is 2x. So when we subtract, we get 0. So we can say the curl does equal 0, so we can also say that f is irrotational. For this example, we want to find the curl of at the given point in space 2, -1, 3 for the vector field f of x, y, z equals x squared zi minus 2xzj plus yzk. Pause the video, try this one on your own, and then come back and check your work. Okay, let's find the curl by setting up a matrix here. The curl f, again this is bold, so I'm going to use that vector notation here, is equal to actually that formula, or you can set up a matrix here and find the determinant of that matrix. The first column is your I column. It's the partial with respect to x, partial with respect to y, and partial with respect to z of the x squared z minus 2xz and the yz. Okay, I'm just taking those components here and putting them in. Now the way you find the determinant is that expansion by minors here. If you cover up that I column, then you find the determinant of this smaller matrix, which is equal to the partial with respect to y, the partial with respect to z of -2xz and yz, that's your I, plus, and then cover up that j column, And you got the partial with respect to x of x squared z, partial with respect to z, yz. That's your j column. I do want to point out here that this really should be a minus. Let me erase that. There. That should be a minus there. Minus. And then that last one, the partial, cover up the k, it's a partial with respect to x, partial with respect to z. That's your k, x squared z, and yz. Now I'm writing it out here, but really when I work this out, I don't even have to write that out because I can cover it up and find the determinant of the matrix. All right, so to do the first one, we want to take the determinant here. If you cover up this first term here, cover up that, and then find the determinant of what's left. Take the partial with respect to y, take the partial with respect to y of yz. That partial derivative is z, minus the partial of this with respect to z. That's going to be minus your negative 2x. That's your I, minus, okay, take that middle one, just cover up that middle term and find the determinant of what's left here. And we take the partial with respect to x of yz, which is 0. Partial of this with respect to x is 0. Take the partial of this with respect to z, and that's going to be x squared. So it's going to be minus x squared. That's your j. And then the cover up that last one. Move that over here and find the determinant of that little 2 by 2 matrix. And the partial with respect to x of negative 2xz, partial with respect to x of, oh, made a mistake over there. Sorry about that. Okay, I'm sorry I did make a mistake on that last matrix. When you cover up that k column, the remaining little 2 by 2 matrix over here, you take the partial with respect to x of negative 2xz, which is negative 2z, and then take the partial of this with respect to y, which is 0, and that's your k vector. When you simplify this, you get if we simplify this, we get the curl of f at any given x, y, z is equal to z plus 2x when we simplify that I. And when we simplify this, we get plus x squared j minus 2zk. So that would be the curl vector function for any point. And we want to evaluate this at our point here, 2, negative 1, 3. So we say let's plug in those values. The curl f, again I'm using that vector notation because the result is a vector. 2, negative 1, 3 at the location 2, negative 1, 3. We're going to plug in 2 for x, negative 1 for y, and 3 for z. So it's going to be 3 plus 2 times 2, I, plus 2 squared j minus 2 times 3k. And when we simplify that, we get 3 plus 4, 7i, plus 4j minus 6k. So that is the value of the curl at the given point in space.